Industrial standards define the short circuit current rating, or SCCR, ratings for electrical equipment. Several standards address SCCR. These include ANSI/IEEE C37.55-2023, which is the standard for electrical power distribution equipment, outdoor pad-mounted, dry-type power enclosures, and associated non-luminous indicators and enclosures. UL 489 is the safety standard for molded case circuit breakers, molded case switches, and circuit breaker enclosures. IEEC 60.947-2 covers low voltage switchgear and control gear, specifically Part 2, which deals with circuit breakers. SCCR ratings are typically designated using a numerical value followed by the unit kA, which stands for kiloamperes. For example, an SCCR rating of 25 kA indicates that the equipment can withstand a short circuit current of 25,000 amps without failing. The SCCR rating of electrical equipment is determined through testing and analysis. The equipment is subjected to a short circuit current of a specified magnitude and duration to test its ability to withstand the fault condition. Several factors can affect the SCCR rating of electrical equipment. Firstly, the type of equipment is important, as different types of equipment will have different SCCR ratings. Secondly, the voltage rating of the equipment affects the SCCR rating. Thirdly, the current rating is a factor to consider. Fourthly, the construction materials of the equipment play a role in its SCCR rating. Fifthly, the physical dimensions of the equipment can also affect its SCCR rating. SCCR ratings are critical for ensuring the safety and reliability of electrical distribution systems. They help prevent catastrophic failures and protect equipment and personnel from damage due to short-circuit currents. It's important to note that the specific SCCR rating required for an application will depend on the system design, fault currents, and applicable codes and standards. It is always recommended to consult with a qualified electrician or electrical engineer to determine the appropriate SCCR rating for a system. Short circuit current rating, or SCCR, is a crucial specification for electrical equipment, indicating its ability to withstand the high currents present during a short circuit fault. Understanding SCCR is essential for ensuring safety, preventing equipment damage, and complying with electrical codes and standards. Electrical codes such as the National Electrical Code, or NEC, require that electrical equipment used in industrial and commercial settings have adequate SCCR ratings. These requirements aim to protect equipment and personnel from the hazards associated with short-circuit faults. The SCCR of equipment is determined through testing performed according to industry standards such as UL 580 for industrial control panels or UL 489 for circuit breakers. These tests simulate short-circuit conditions and measure the equipment's ability to withstand the resulting currents without causing a fire, explosion, or other hazardous condition. Several factors influence the SCCR of electrical equipment. These include the type of equipment, its voltage and current ratings, the materials used in its construction, and its physical size and design. For example, a circuit breaker with a higher interrupting capacity will generally have a higher SCCR than one with a lower interrupting capacity. Similarly, equipment constructed with more robust materials and a more rugged design will typically have a higher SCCR. Electrical equipment manufacturers provide SCCR ratings for their products, typically marked on the equipment nameplate or in the product documentation. This rating indicates the maximum short-circuit current that the equipment can safely withstand. It is essential to select equipment with an SCCR that is equal to or greater than the available fault current at the equipment's location in the electrical system. Calculating the available fault current is a critical step in determining the appropriate SCCR for electrical equipment. Fault current calculations involve analyzing the electrical system's impedance, voltage, and transformer characteristics to determine the maximum current that could flow during a short-circuit fault. These calculations are typically performed by qualified electrical engineers or using specialized software tools. The available fault current can vary depending on the location in the electrical system. It is generally higher closer to the power source, such as the utility transformer, and decreases as you move further away due to the impedance of conductors and other equipment. Therefore, it is essential to calculate the available fault current at each location where electrical equipment is installed to ensure that the equipment's SCCR is adequate. If the available fault current exceeds the equipment's SCCR, several mitigation methods can be employed to reduce the fault current or increase the equipment's SCCR. These methods include using current-limiting fuses or circuit breakers, adding impedance to the circuit, or replacing the equipment with a higher SCCR-rated device. Current-limiting fuses and circuit breakers are designed to quickly interrupt the flow of current during a short-circuit fault, limiting the magnitude and duration of the fault current. These devices can significantly reduce the stress on electrical equipment and prevent damage or failure. Adding impedance to the circuit, such as through the use of reactors or resistors, can also help to reduce the available fault current. These devices introduce additional opposition to the flow of current, limiting the magnitude of the fault current. Replacing equipment with a higher SCCR-rated device is another option, although it may be more costly and time-consuming. This approach involves selecting equipment with an SCCR that is equal to or greater than the available fault current at the equipment's location. Proper coordination of SCCR ratings is essential for ensuring the overall safety and reliability of electrical systems. This involves selecting equipment with SCCR ratings that are coordinated with the upstream and downstream protective devices such as fuses and circuit breakers. Coordination studies are typically performed by qualified electrical engineers to ensure that the protective devices will operate correctly during a short-circuit fault, minimizing the impact on the electrical system and preventing cascading failures. In addition to complying with electrical codes and standards, implementing a comprehensive SCCR program can provide several benefits for industrial and commercial facilities. These benefits include improved safety, reduced downtime, and low maintenance costs. By ensuring that electrical equipment has adequate SCCR ratings, facilities can minimize the risk of electrical fires, explosions, and other hazardous conditions, protecting personnel and property. Properly coordinated SCCR ratings can also reduce downtime by preventing equipment failures and minimizing the impact of short-circuit faults on the electrical system. This can help to improve productivity and reduce lost revenue. Furthermore, a comprehensive SCCR program can help to lower maintenance costs by preventing equipment damage and extending the life of electrical equipment. This can reduce the need for costly repairs and replacements. The ANSI/IEEE C37.55 standard provides requirements for outdoor pad-mounted, dry-type power enclosures and associated non-luminous indicators and enclosures. This standard covers the design, construction, and testing of these enclosures, including requirements for SCCR. UL 489 is the safety standard for molded case circuit breakers, molded case switches, and circuit breaker enclosures. This standard specifies the requirements for the design, construction, and testing of these devices, including requirements for SCCR. IEEC 60.55-2023 covers low-voltage switchgear and control gear, specifically Part 2, which deals with circuit breakers. This standard provides requirements for the design, construction, and testing of circuit breakers, including requirements for SCCR. The SCCR rating is typically marked on the equipment nameplate or in the product documentation. This rating indicates the maximum short-circuit current that the equipment can safely withstand. It is essential to select equipment with an SCCR that is equal to or greater than the available fault current at the equipment's location in the electrical system. The available fault current is the maximum current that could flow during a short-circuit fault. This current can vary depending on the location in the electrical system. It is generally higher closer to the power source, such as the utility transformer, and decreases as you move further away due to the impedance of conductors and other equipment. Factors affecting SCCR ratings are several. These include the type of equipment, the voltage rating, the current rating, the construction materials, and the physical dimensions. Different types of equipment will have different SCCR ratings. For example, a circuit breaker will typically have a higher SCCR rating than a disconnect switch. The voltage and current ratings of the equipment also affect the SCCR rating. Higher voltage and current ratings generally result in higher SCCR ratings. The construction materials used in the equipment also play a role in the SCCR rating. Equipment constructed with more robust materials will typically have a higher SCCR rating. The physical dimensions of the equipment can also affect the SCCR rating. Larger equipment will typically have a higher SCCR rating than smaller equipment. SCCR ratings are critical for ensuring the safety and reliability of electrical distribution systems. They help prevent catastrophic failures and protect equipment and personnel from damage due to short-circuit currents. A short circuit is an abnormal condition in an electrical circuit where current flows through an unintended path, bypassing the normal load. This can result in a large surge of current, which can cause damage to equipment, start fires, and pose a risk of electric shock to personnel. SCCR ratings indicate the maximum short-circuit current that a piece of equipment can safely withstand without causing a fire, explosion, or other hazardous condition. Selecting equipment with adequate SCCR ratings is essential for protecting the electrical system and personnel from the hazards associated with short-circuit faults. Several resources are available to help determine the appropriate SCCR ratings for electrical equipment. These resources include electrical codes and standards, equipment manufacturers' data, and qualified electrical engineers. Electrical codes and standards, such as the NEC, provide requirements for SCCR ratings in various applications. Equipment manufacturers typically provide SCCR ratings for their products in their product documentation. Qualified electrical engineers can perform fault current calculations and provide guidance on selecting equipment with appropriate SCCR ratings. Ongoing maintenance and inspection of electrical equipment are essential for ensuring that the SCCR ratings remain adequate over time. This includes regularly inspecting equipment for signs of damage, such as cracked insulation, loose connections, or corrosion. Any damaged equipment should be repaired or replaced promptly to prevent potential short-circuit faults. It is also essential to ensure that the electrical system is properly grounded to provide a low impedance path for fault currents to flow back to the source. Proper grounding can help to reduce the magnitude and duration of fault currents, minimizing the stress on electrical equipment and improving the overall safety of the electrical system. Proper labeling and documentation of SCCR ratings are essential for ensuring that the information is readily available to personnel who need it. This includes labeling equipment with its SCCR rating and maintaining accurate documentation of fault current calculations and coordination studies. Clear labeling and documentation can help to prevent errors and ensure that equipment is properly selected and installed. Training personnel on SCCR requirements and best practices is essential for ensuring that they understand the importance of SCCR ratings and how to select and maintain equipment with adequate SCCR ratings. Training should cover topics such as fault current calculations, coordination studies, equipment selection, and maintenance procedures. Properly trained personnel are more likely to identify potential hazards and take appropriate actions to prevent short-circuit faults. Implementing a comprehensive SCCR program can be a complex undertaking, but it is essential for ensuring the safety and reliability of electrical systems. By following the guidance provided in this discussion and consulting with qualified electrical professionals, facilities can develop and implement an effective SCCR program that protects equipment and personnel from the hazards associated with short-circuit faults. Remember, the specific SCCR rating required depends on the system design, potential fault currents, and relevant electrical codes. Always consult with a qualified electrician or electrical engineer for guidance.